Well, somebody sent a comment about showing how they're actually done repairs. Is it just a tune-up? Well, I've never seen a Team TRX404 UK ever before in my life, and I've got no circuit diagram and no service manual. It's got a stub of a power lead. Now, with two options with power leads: do I repair that and put a fuse holder in it and charge them $3.79, or do I supply a brand new power lead and charge them $1.99? I'm sure it would cheer them up more if we do the latter, so that's what we'll do. And while I plug that in, we'll pause the video. Right, having plugged it in, I've prepared a new mic. And I notice it not only has a microphone socket, but it has a selective calling socket as well, and that is unusual. And what have we got here? On off volume squelch, Roger bleep on and off, VSQ. Oh, it'll be the cell call, won't it? Right, well, that looks interesting, as I've never seen inside one of these, so we will. Oh my goodness. We'll unsolder the speaker lead and see what we can see. Right, well, looking at the circuit, and I can't think I remember seeing this layout before, it's another of these sets with the mixer crystals like the ICOM I was just showing you, and the DNT M40, but it's a different layout. Is it the same as the Radio Technic RT852? I've only ever seen one of those. So I haven't a manual, I've got a good idea of how the circuit works, because it's going to be the same as those DNTs. So I presume we set the. It all has to be educated guesswork. So I presume we start by setting checking the VCO is set. The radio kind of works. It just needs servicing. So if I go for, like we would on the ICOMs, we'll check that we've got about 5 volts on the pin 8 of the synthesizer IC. I'll just put the radio into transmit. Yeah, that looks about how it's done. That's logic high. Let's select channel 1. That's 5 volts-ish on receive, 5 and a bit volts on transmit, 5 volts on receive, and 5 and a bit on transmit. So I suspect that's how we just check the VCO. So that's that done. Luckily it didn't need adjusting, but if it did, so I've got no circuit references, that will be the VCO coil, should it have needed adjusting. Now what I'm going to have to do is to do a frequency check of the 10.24 reference oscillator. I'm not sure I like these crystals dangling. We've got the 10.24, you've got the transmit and receive crystals, mixers there, and then looks like we've got a crystal filter as well for the receiver. Anyway, I'm not saying these are my favourite kind of circuits, but and then I wouldn't say these are brilliantly made sets either. So that's what I'll do. I'll just pause the video and I'll just do that check. What I'm going to do is put my test prod onto pin 3 of the synthesizer chip, and we'll make sure that we get the reference oscillator here. There's a preset just under there. We'll get that adjusted for 10.24, and then we've got a starting point. I did some very quick checks and noticed that it's doing about 2.5 watts on transmit, so let's hope that we can improve that for the customer. I'm going to pause the video again. Now, I wasn't quite able to pull that up to frequency. As you're probably aware, crystals drop with age, and it should be 10.24, it's 10.39990. Now that could cause the receiver to start performing in a funny way, so we'll see what happens as to whether I have to reject the set or what. Now, we need to set the transmit frequency, and I'll just have to work out which one of the two trimmers is the transmit one and which one is the receive, because as I say, it's got a mixer, and that needs to be just taken into consideration. Right, I've made a little diagram up here of what I can spot, and it's educated guess. Now all these coils are filled with wax, so I'll just have to pop the soldering iron in the top very carefully. This is the first transmit one by the looks of it. That's correct, and that's optimised that. I don't know whether this is transmit or receive, but at least if I get it wrong, I've got the test equipment to put it back. No, that could well be receive, so we'll leave that well alone. This one's definitely going to be transmit. Needs a bit more heat. The last thing we want to do is break any of these cores. That's done it. That's optimised. Can't see or feel these. Don't say these are sealed as well down there. No, I can't feel that one. May well have to take the screen off to do this. Oh, that one's moved. Ah, that's better. That's brought it up from 2.5 to 3.5 watts. These three here have cores? No, they don't. Now I'm going to have to pop that screen cover off and just see what's going on under there. I'll pause the video again. Now what taking that covers off has revealed, no wonder I couldn't feel it, it's got a broken core. Now then, the other one which we've revealed is that one which adjusted fine, but this one, it's all mangled up. And what I'm now going to have to do is unsolder the coil, and try and remove the core from the underside. See how we do with that. So I'm just going to stop the video and do that bit of work. Okay, what I've done now is to take that coil out. We don't have replacements, we don't have replacement cores, so you'll find this quite interesting. What I've done is to take out the broken core, which I've been able to do because once you've taken the coil out, you can get the trimming tool in the underside of it. So I've removed that because it had wax in it, so I had to do that. And then I've cheated. You may think this is a bodge, but I've turned the core round so the good bit is now to the top and the bad bit is to the bottom. And of course in doing that I've removed the broken bits. The radio has now tuned up through that one and that one to 4 watts. Now the way that's been assembled into the radio was on a slight angle, so someone will have come along, put the trimming tool in correctly through the top and mashed it up, but I felt it was wrong and it was broken. So we'll put the cover back on and we'll carry on from there. So now we've got 4 watts full transmit power out of this previously unknown set. That does conclude the transmitter. It's on frequency, it's doing the right power, but there's 2 aspects, and one is the RF meter and the other is the deviation. Now I've got 1, 2, 3, 4, 5 variable resistors in front of me here on this radio, and I haven't got the foggiest idea which one is which. So whatever I upset I can reset because I've got the test equipment. So I'm going to power it up see how many of these lights light up. All of them do. Fair enough. But I want better confirmation than that. So I'm just going to go down all these 5 presets until I find the right one. Well, it isn't that one. And it isn't that one. And it isn't that one. It's ridiculous, this. And it's not that one. It's the final one. So I've set that to the last bar just lights. Now then, I'll write on my chart, for future reference, that, and I'll just get the magnifying glass onto the board. Can I see anything? RV 45. So that is RF meter. So the next one we need to find is deviation. Well, deviation. Well, let's have a look. We'll put the radio into transmit. Get our little oscillator out. And we've got approximately 2 kilohertz deviation. So we'll go down these again. It's not that one. It's not that one. It's that one. Wallow. That's correct. So I'll make a note on my chart. It's deviation. It's the 3rd one down. And does it say anything? 122. So that leaves 3 presets we've upset, and I just hope one of them isn't the cell call level. Haha. Not that I expect they're using it with it, but you know, this is what happens when you've got no manual and you've got to take a guess. Well, that concludes it. We've got the transmitter on power, on frequency, correct deviation, and the RF meter reading correctly. So we'll stop the video at that, and we'll cover the receiver on another video.